a reusable launch vehicle being mastered by the Indian Space Research Organization. The final RLV, or the reusable launch vehicle, will be about double the size of this. This is a scaled model, and ISRO has tested it twice successfully in the scaled model test. I have with me Mr. Sunil, who's the program director for the group which is leading the reusable launch vehicle. Sunil sir, what is the importance of this reusable launch vehicle which we see here?
This particular vehicle is basically a forerunner to the future two-stage to orbit or single-stage to orbit. So if you see the vehicle as such, as you can see, there are different parts, different important components in the system. That basically, if you see the wings, this gives the lift for the vehicle. And
which is what makes it
stable. During flight. It gives a sufficient lift to take it through the atmosphere and then land at a particular location. And there are this we call as rudders and ailerons, which can give you control, which controls the vehicle through the flight. As we move forward, this is the leading edge of the wing, and this is the overall body of the vehicle, and this houses the avionics systems.
So which is where you will house finally the avionics?
Yeah, avionics is going to come inside the system. We have all the control systems, everything is going to be there. Then as you move forward, and one more thing what I like to point out is that during the flight through atmosphere, it requires a lot of heat is generated. Like any other re-entry vehicle, there will be heat generated. So it will have a thermal protection system when it goes to the final configuration of the orbital re-entry vehicle.
Now, let's stop here and talk a little bit. The only reusable vehicles which we have seen is the space shuttle by America, which used to carry astronauts. It has been retired. And we had Buran by Russia, which flew only once. In the 21st century, when everybody else has retired doing reusable winged rockets, why is ISRO doing winged rockets?
ISRO is having an objective to fly a vehicle which is more cost effective, economically viable, so that we can have very low cost access to space. So this vehicle actually satisfies that need because it is going to have a configuration where the stage is going to fly back. So we can reuse the stage and then go ahead with the next mission. So that way we can bring down the overall cost to orbit. So that's a basic intention.
Now, see, in reusability, most people see those images of the SpaceX rockets coming back. They are only hollow stages which they are bringing back. It may be complicated avionics to bring it back, but bringing the upper stage, which is the most expensive electronic part, is that the game changer for the idea for ISRO?
No, what ISRO is looking at is, we should, as I told earlier, we should have a low-cost access to space. So when we move forward to a TSTO sort of vehicle, we can fly.
Which is two-stage to orbit.
Two-stage to orbit, where we can fly back the first stage, and the topmost stage, or the upper stage, can carry a satellite, put it in the orbit, and then come back. So there is an advantage there. Here, when you take SpaceX, they are trying to bring back the spent stage back to Earth by using electropropulsion. So both are reusable, but we have some advantage of getting the basic vehicle go to orbit and bring back the stage.
Which also has the brain and the most expensive part.
Exactly.
Because a hollow tube is a hollow tube.
Right.
Whereas the brain upper part which we are trying to do is the more expensive part. Now, how difficult and what is important about the cone? Because all of this would be where heat would be generated when it is coming back.
We have, as I told earlier, this vehicle will be bonded with thermal protection system because it has to take care of the heat which is generated during the atmospheric re-entry. And we have tiles, silica tiles at the bottom region, and we have flexible insulation on the top. Why flexible insulation is, here the heat flux is going to be much lesser compared to the bottom face, which is going to face the flow. And when you move forward, this is a nose cap. Here, this nose cap also will be seeing very high heat because your diameter is less and it's going to.
So what material is this?
This carbon.
Carbon.
This is what material what we use to stand higher temperatures. Because here we are going to see very high temperatures.
Now, what has been the two tests which have been done?
See, we did a re-entry experiment initially, a high altitude test initially. It's called technology demonstrator for RLV, which flew at an altitude and then came back. And second is the landing experiment, which we read recently in last April, which was a successful mission. And now we are planning for the next landing experiment, because always we need to have a follow-up mission so that we can prove the technology.
Now let's take a look on the other side also. So both sides look very similar.
Yes, exactly. It's a symmetric body. It's a symmetric body because being a flying system, it should be symmetric. It's having wings on both sides. Then only you can have. Then it is having the landing gear.
The landing gear is similar to what an airplane would have.
Similar to that. Similar to that. Only thing is that loading part is going to be different. That depends on the vehicle what's being fitted to. So we have 3 landing gears. This we call as a nose landing gear, and we have 2 main landing gears, because when it lands on the main landing gear first, and then nose landing gear is going to touch down. So this experiment we are able to successfully do in next mission.
So how soon can we have the final orbital mission, and how soon can we see a full configuration of the reusable launch vehicle flying from
It
India?
will take some more time for us, because now we are in the phase of developing the critical technology. It may take another 2 or 3 years time frame for bringing all these things together into one system and then fly. So definitely it's in the offing.
Now, we've named it Pushpak. Is it after the famous Pushpak Viman that we've named it? What is the...
We can take it so, because it's in the mythology, it is there. So we can take it so.
So this is India's reusable launch vehicle. 2 tests have been done. A final orbital test will be done, and then the full system will be deployed very soon. India wants very low cost access to space. Named Pushpak, could be after the Pushpak Viman, the famous Pushpak Viman, which is mentioned in the Ramayana. But ultimately, low cost access to space is going to decide how you and I benefit from space technology. Thanks a lot, Mr. Sunil.
Thank you.
So nice of you to speak to us.
Thank you.
So that was the